Hey, welcome back to PSLE Math Lab. Today, let's solve a counting problem. Without repeating any digits, how many 5-digit number which is divisible by 4 can you form from the digits 2, 5, 6, 7, and 8? If you would like to give this problem a try, pause this video now. Well, we can make some quick observations from reading the question. First, we are to form 5-digit numbers with 5 different digits. So the total combination of numbers which we can create without repeating can be calculated easily by multiplying 5, 4, 3, 2, and 1, which is equal to 120. This gives us a boundary, a range for the final answers, as only a subset of these 120 numbers is going to be divisible by 4. Second, any number that is divisible by 4 had to be divisible by 2, so obviously the last digit can only be 2, 6, or 8. If the question were to ask us how many 5-digit number is divisible by 2, we could already use this to calculate the answer, as only the last digit matters in determining if a number is divisible by 2. But because the question asks for divisibility by 4, we need to focus on the third observation, which is we need to find a way to form a 5-digit number which would guarantee its divisibility by 4. Now we have a focus and direction. Let's do some exploratory thinking. Pick a random 5-digit number formed by these 5 digits. Of course, we're going to pick an even number. In this case, let us pick 25,678. So we can break this number down as 256 times 100 plus 78. We know that 100 is divisible by 4. In fact, 100 is equal to 25 times 4. So left side, 256 times 100 is always going to be divisible by 4. This means we only need to check if 78 is divisible by 4 to know whether this 5-digit number is actually divisible by 4. Of course, in this case, 78 is not divisible by 4. So what does this mean for us? Well, it means that we have an intermediary finding which says if any number is to be divisible by 4, the 2-digit number formed by its last 2 digits must be divisible by 4. Awesome! Now we have the definitive answer to the key question that we posed to ourselves. We now know how to form a 5-digit number to guarantee that it will be divisible by 4. So let's start counting. So let's draw 5 boxes representing the 5 digits we need to fill up to form the 5-digit number. And let's start by filling the boxes from right to left. We only need to focus on the last 2 boxes on the right, as the last 2 digits determine the number's divisibility by 4, as we learned from the intermediary findings. So why don't we start with fixing the last digit to 2. So for the 10th position, we have the remaining 4 digits as 4 different possibilities. And let's evaluate these 4 possibilities one by one. 52 is divisible by 4. 62 is not. 72 is divisible by 4. And 82 is not. And for the remaining digits in front, we can actually freely fill up the boxes without worrying too much. We have used up 2 digits already with 3 digits remaining, so filling the 3 boxes in front, not repeating, we would have 3 times 2 times 1 possible combinations. So in total, we have the possible 5-digit numbers ending with 2 that is divisible by 4 to be 2 times 3 times 2 times 1, which is equal to 12. But remember, we have other possibilities for the last digits. Next, let's fix the last digit to be 6 And obviously we will be skipping 5 and 7 as they're not even numbers. And considering the 4 possibilities to fill up on the 10th position, we evaluate these 4 possibilities one by one. 26, not divisible by 4. 56, yes. 76, yes. 86, no. So again, we have a similar situation as last time. We can easily calculate the number of possible 5-digit numbers ending with 6 to be divisible by 4 to be 2 times 3 times 2 times 1 again, which is 12. And last but not least, we fix the last digit to be 8. And having gone through the previous 2 rounds, we can quickly find out that only 28 is divisible by 4 out of the 4 possibilities, which gives us a total of 1 times 3 times 2 times 1, 6 possibilities to form a 5-digit number that's divisible by 4, which ended with number 8. So we have finished thus far considering and counting all the possible combination of 5-digit number formed by these 5 digits that is going to be divisible by 4. And we only, as the last step, need to add all of these things together. And now, last but not least, let's add the 3 previous rounds of calculations together to give our final answer, which is going to be 12 plus 12 plus 6 equal to 30. And that is your final answer. But before you go, I encourage you to try solve this bonus question. Notice that the answer 30 is actually 1/4 of the 120 total possibilities of the 5-digit numbers we can form. Can you think of another way to show that this 1 out of 4 probability relationship? You can refer to the pinned comment for a small hint. Like and subscribe if you find this problem interesting and have learned something new. And don't forget to turn on the notification to keep up with our latest videos. Thanks for learning with us and see you next time.